Welcome to the office. We want to take a look at an example of finding the product of permutations when they're written in cyclic notation. So composition of permutations, of course, we want to remember that permutations are functions. So let's take a look at our example. We want to find the product sigma tau of the cycles. So really these are permutations. Maybe that's some bad language there of the permutations. They're in cyclic notation, but they themselves are not cycles. Find the product of the permutations. So we're clarifying that this is in S10 because not all of the numbers appear here in sigma. They do appear here in tau, but not all of them appear here in sigma. And actually, I think not all of them appear here because these are both things that we have worked with before. All right, so if I want to find sigma tau, that composition, I can write that down. Sigma is 2, 5, and then 1, 6, 3, 4. Tau is 1, 4, 3, 10, 7, 5, 9, 6, 8. So in this composition, I want to work from right to left. How exactly you start it doesn't really matter. The end result should be something that has disjoint cycles, so it shouldn't matter. But what we want to remember is that this is sigma and this is tau. So when I go to evaluate this, I want to look at what's happening. Because I am focusing here on sigma and tau, I could start with tau, what happens at 1, and then work on from there. However, it's a little bit more efficient, especially as we look at larger products where we're not specifying it as sigma and tau, right? Just trying to simplify products of cycles that may or may not be disjoint. We really should start all the way to the right because really this is 1, 2, 3, 4, 5 different permutations that are all cycles. So this is really the composition of 5 functions. So let's go ahead and start all the way at the right and observe what happens. Now, again, them being disjoint is going to allow us to not worry about order over here in terms of the order of the cycles. So let's see here. I'm going to start with 5 just because that's our first cycle. 5 goes to 9. Now, since I'm working with tau and then sigma, oh, look, 9 just goes to 9. So 5 goes to 9. That's fine. If I don't know that this is sigma times tau, I would say, all right, 5 goes to 9. That doesn't tell me where 9 goes. 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 So I'm done. 5 goes to 9. All right. Now 9 goes to 6. And then where does 6 go? So maybe clarify here. Sigma fixes 9. So 9 does go to 9. 5 goes to 9. And here, according to sigma, 9 goes to 9. So 5 goes to 9. Now, where does 9 go? Well, 9 goes to 6. And then I can observe that 6 does not appear here, 6 does not appear here because tau is written as a product of disjoint cycles. And here I can see that 6 goes to 3. And then, of course, 3 doesn't go anywhere else. I should continue to check because I don't always know that they're going to be disjoint, but 6 goes to 3, and that's it. So 3. Now, where does 3 go? Well, 3 doesn't appear here, of course. So 3 appears here, and 3 is sent to 10. That's what tau does to 3. Now, what happens to 10? 10 is fixed under sigma, so 10. Now, what happens? Well, 10 gets sent to 7. And I continue to work this way. I don't look at what happens over here anymore. And I just continue on until I'm all the way to the left. So what happens to 10? 10 gets sent to 7. Oh, look, 7 is fixed here, so it goes to 7. What happens to 7? Well, 7 goes to 3, and 3 goes to 4. Excellent. So 4. I should continue to check, but there's no 4 doesn't appear again. So what happens to 4? Well, 4 gets sent to 1, and 1 gets sent to 6. And that's it. What happens to 6? 6 gets sent to 8. What happens to 8? Oh, 8 is fixed by sigma, so it's just 8. What happens to 8? 8 gets sent to 5. So we go, okay, well, now that tau takes 8 to 5, what does sigma do? Well, looking at the individual products, this doesn't send 5 anywhere, this doesn't send 5 anywhere, this doesn't send 5 anywhere. Oh, hey, look, this one sends 5 to 2. Fantastic. Now what happens to 2? Oh, 2 is fixed here. 2 is fixed, so 2 gets sent to 2. And what happens here? Oh, 2 gets sent to 5. That places us back here, and we're all set. So what I should do is I should check for anything that's not appearing here. I don't have 1, for example. So what happens to 1? 1 gets sent to 4. 4 gets sent to 1. So 1 is fixed. I don't need to write it down. 2 is appearing, 3 is appearing, 4, 5, 6, 7, 8, 9, and 10. So all of the other elements appear. So the product sigma tau is a large cycle that fixes 1. Excellent. And that's it for our example. It won't always result in one large cycle. That did happen in this example, and it did happen in, oh, it did. Yeah, I suppose it did happen in the others as well, where this example fixed one element, those fixed one element. That is just happenstance, or maybe a poor choice of examples. I'm not sure which. But you will see examples where the result is multiple cycles. So take a look at the book, or search for more examples, product of permutations in cyclic notation, to find some more examples. That would be a fantastic idea. All right, I'll see you guys back here in the office, because we do want to continue on talking more about permutations, cyclic notation, that sort of thing. And we're going to do that moving on to the idea of even and odd permutations. So I'll see you guys back here in just a moment.